continuing with 2.4. You previously saw long division with polynomials, which took a little bit of time, had a little bit to it. We'll see an easier way that we can divide polynomials using what they call synthetic division. So seen here is an example to help you out. Along the way, I'll break this down and tell you what's going on. So we're acknowledging that in our denominator we have x plus 3. We can then take the 0 of this divisor, so x minus 3. If we solve this, x minus 3 equals 0. Eventually, x would have to be equal to 3, so that's where this 3 comes from. We're then using the coefficients of the dividend, so our numerator term coefficients here were 2, -3, -5, and -12. All in sequential order from the highest exponent to the lowest exponent. We then go about this by taking the first coefficient, we drop that like it's hot. We then take the product of the 0 and this coefficient, we bring that over here, and then it's just a bit of arithmetic. So -3 plus 6 gets us 3. We then rinse and repeat. We take the 0 of the divisor, 3, multiply it with this 3, get 9. Break this all the way down, 3 times 4 gets you 12, gets you here. So this is saying that since this is a form of division, there's no remainder. This last part here shows that. But we use the quotients to build together where exactly the quotient is. So 4, as we go from right to left, the 4 is the constant, 3 is your coefficient for x, and 2 is your coefficient for x squared. Ideally building the polynomial back up, going from lowest exponents to higher exponents. So we'll do the same thing here for this example. If we look at our divisor, x plus 1, the root of this, so the root or the 0 of this divisor is going to be -1. So how do we set this up? We know that we can use this same kind of format. If we throw -1 to the left, we write in our coefficients for our dividend up here. So the coefficient for x cubed is going to be 1. We then have -2, and then 3, and -6. We're dropping that first coefficient like it's hot. Taking the product of -1 and 1 will get us -1. That goes here. -2 minus 1 gets us -3. -1 times -3 gets you +3. 3 plus 3 gets you 6. -1 and 6 gets you -6. -6 minus 6 gets us -12. We have our remainder here of -12. If we build back our polynomial, our quotient from here, we have a constant of 6. That's positive. We're then deducting 3x. We're then adding on x squared. And our remainder is -12. So it's important to notice that we have a remainder, which is nice. It's also important to notice the quotient. So you need to kind of hold all of this together. What's cool is that if you decide that you want to check your work on this, you could FOIL all of this out. You could have x squared minus 3x plus 6. You could FOIL this with x plus 1. I'll actually show this example. You then have x cubed, you're subtracting 3x squared, you're adding on 6x, you're adding on 6, you're deducting 3x, and then you're adding on x squared. This gets you pretty much back to the original divisor, or sorry, the dividend, which is important, because you end up with x cubed, you end up subtracting 2x squared, seen here, you end up with plus 3x, and you end up with plus 6 here, but notice, your remainder is -12, so when you throw in that remainder, that gets you that -6, which was mentioned. So you can always check your work by foiling or box method. It's nice, it's convenient, it's helpful. We can also use this to end up with the values of certain x values, and we don't really feel like plugging in this value of 2. So synthetic division really helps us out, and I'll show you how. So we set this up the same way that we previously did, where instead of taking the opposite, we just take the number that's given. So if we have 2 and plugging that in, put that there. Coefficients for our polynomials seen here go in accordingly. We drop that 8 like it's hot. Taking the product of 2 and 8 gets us to add on 16. 6 and 16 gets us 22. 2 times 22 adds on 44. 2 and 44 gets us 46. 2 times 46 gets us 92. 4 and 92 gets us 96. 2 and 96 gets us 192. So this arithmetic seems as if it's kind of senseless, and it kind of is. It is a little tedious, but trust me, this is easier than just plugging in this, evaluating 2 to the 4th, and then evaluating 2 cubed and all that. Eventually, when we bring these together, our answer will be 202. So this is a simplified way to evaluate numbers in a polynomial. What's cool is that you can check this. This is similar to how we've plugged in values before and we double checked on if it works or not. If we check and we graph out all of this seen here, we soon see that when this is all said and done, it looks pretty crazy, but we see that when x is 2, it does in fact intercept there, which is pretty crazy to see. But look, like I have to go in super close to show you that this is going to intersect. So this is another way that you can evaluate numbers in a polynomial, and this is using synthetic division. The remainder is your outcome that you would want.